Hello everyone, I am Arshit from Sri Venkateshwara College of Engineering. Today I am here to solve the expression that is the conversion of epsilon NFA to its equivalent NFA. Here you can see the expression of epsilon NFA where it consists epsilon in these expressions. So we have a task that we should convert this epsilon NFA to its equivalent NFA. To solve this, there are three steps. First is we should apply epsilon closure to the three states, that is A, B and C. Then we should give the input for the same which we got from epsilon closure of the states. Then after getting the outputs from giving these inputs, we should again apply this epsilon closure to these outputs. Then we are going to write it down here. Before solving this, let me see what is epsilon closure. Epsilon closure is nothing but it is all the states that can be reached from a particular state only by seeing the epsilon symbol. For example, A, on seeing epsilon symbol, it can go to A itself, then it can go to B. So A can reach all the states by seeing epsilon. Then as it's the same, B on seeing epsilon it goes to the B, then on seeing epsilon it goes to C. Then the C on seeing epsilon it goes to C itself. Now we will apply the epsilon closure to the each states one by one. For A, on applying epsilon closure, as we know that we will get A, B and C. So we will write out the three states obtained on A on applying epsilon closure, that is A, B and C. So before this we will write the transition table outline, that is we will write the three states A, B and C. Then the inputs, that is 0 and 1, as we can see only the two inputs, that is 0 and 1. So A is the initial state. We will mark this by giving the arrow symbol which determines the initial state. So we got A, B, C on applying epsilon closure on A. Then we will apply input 0 to A. On applying 0 to A goes to A. So we will write it down here as A. B, on applying 0, it does not go to anywhere. So it's written as 5. It is C, on applying 0, it goes to C itself. So we'll write it down as C. Then again we are going to apply the epsilon closure to all these three outputs which we got here. For A, on applying epsilon closure, we will get the same thing, that is A, B and C. So we are going to write it down the three states which is A, B and 5, which is empty set. We are not going to apply anything here. Then for C, on applying epsilon closure, it goes to C itself. So we'll write C here. Then for the same state A, now we are going to apply the input as 1 here. A on epsilon closure, as we know already that we will get the three states, that is A, B and C. When we give the input 1 to A, it does not goes to anywhere. So write it down here as 5. Then for B, on applying 1, it goes to B itself. Then it does not goes to anywhere. So write B only here. Then again for C, on applying input 1, we will get 1 itself. So we are going to write. Then for this outputs, we are going to apply epsilon closure. By say empty set, we know that we cannot apply anything for this. For B, on applying epsilon closure, we will get B and C. So we will write it down B and C here. Then for C, applying epsilon closure. On applying epsilon closure for C, it goes to C itself. So write it as C. Then after completing one state which is A, we should fill these outputs in this transition table. The last thing which we got here on A, for A on applying epsilon closure, as taking input 0, we got A, B, C, C, which is nothing but A, B, C. If there is two same states, we will consider it as 1. So we'll write it as A, B, C. with enclosing curly braces. Then for A on applying 1, we will get B, C and C. So we'll consider it as only B, C. So write it the same B, C enclosed with curly braces. The same thing we are going to apply for B. B on giving B, when we apply epsilon closure to B, B goes to B itself and it goes to C. So write it down B and C. Then for B on applying 0, it goes to nowhere. So it cannot go to anywhere. So write it down as 5 here. Then for C on applying 0, it goes to the same state which is C. And we know that we cannot apply epsilon closure to this pi which is empty set. So we are going to apply the epsilon closure to C. On applying epsilon closure to C, C goes to C itself. So we go into write C here. Then the same thing we will apply for B. On applying epsilon closure, we know that we will get B and C. On applying 1 to B, we will get B and C. On applying 1 to B, we will get the same state which is B itself. So we are going to write it down as B. Then again for C on applying 1, it goes to C itself, the same state. The same we are going to write here. Then we are going to apply the epsilon closure again to B. On applying epsilon closure to B, B goes to B itself, then it goes to C. We will write it down as B and C here. For C on applying epsilon closure, it goes to the same state which is C. We applied for the two states, that is A and B. For C, we are going to write it down directly, which is for C on applying 0, we will get the same thing, that is C only. And for C on applying 1, we will get the C, the same thing again, the C itself. So for this one, you can check it out, you will get the same thing. So we completed the transition table. Now we are going to write the transition diagram, which we will see in this next slide. The transition table is now completed. Now we are going to write the transition diagram for this. Before writing the transition diagram, let me conclude which are the initial and final states. We already know that A is the initial state. In previous slide, you can see that C is only the final state because this is the epsilon NFS expression. Now we are going to convert it to its equivalent NFA. So the final states are going to change here. The states which can reach the final state, that is C, through seeing the epsilon are considered as the final state. So A, by seeing epsilon, it goes to B. Then B on epsilon, it goes to C. So it reaches the final state from A to C by seeing the epsilon. Even B, by seeing epsilon, it reaches C, and C is already a final state. Now all three states will become the final states. So we will mark it as a circle for these three states, which is A, B and C. Only A is the initial state, but the final states are all the three states, which is A, B, C. So now the initial states and final states are concluded. So now we will see how to draw the transition diagram. First we will take the single state, which is A. We already know that all the three states are final states. For final state, we will give the double circle to that. So the state A, on the input 0, it gives A, B and C. So on input 0, it goes to A itself, that is A. For B, on input 0, it goes to B. Then for C, it goes to C by seeing the input 0. Then for A, on applying the input 1, it goes to B and C. The same thing we'll mark here. A on applying 1, it goes to B. Then for A on applying 1, it goes to C. Then for B on applying 0, it goes to C. B on applying 0, it goes to C. We'll mark here by giving the arrow mark and writing 0 here. Then B on applying 1, it goes to B and C. B on applying 1, it goes to B itself. Then on applying 1, it goes to C. C on applying 0 or 1, it goes to C itself. So write the self loop here. C on applying 0, 1, it goes to C itself. So this is how we write the transition diagram for NFA. Like this, we are going to convert the epsilon NFA to its equivalent NFA. So thank you for watching this video.